This is the OCR GCSE 91 Maths Paper 6 from the November 2021 series, and this paper is a calculator paper. Question number 1. The table shows the names and areas of 5 lakes. We've got the name of the lake in this first column. In the second column, we've got the area in kilometers squared. For part A, we have to write the area of Lake Mawuru as an ordinary number. Well, here is its area, 5.12 times 10 to the 3. We need to write this as an ordinary number. Now we've got this 5.12 and we are multiplying it by 10 to the 3. 10 to the 3 is the same as 1000. We are multiplying 5.12 by 1000. The result of that calculation is equal to 5,120. So the area is 5,120. For part B, we have to write the lakes in the order of their area, starting with the smallest. Well, to find out which area is the smallest, we take a look at the powers of 10. The smallest power of 10 is this, the 10 to the 2, followed by the 10 to the 3, followed by the 10 to the 4. So the smallest one will quite simply be the 9.86 times 10 to the 2. Now if I compare the 5.12 times 10 to the 3 with the 3.20 times 10 to the 3, the smaller one will be the 3.20 times 10 to the 3. And then the third is the 5.12 times 10 to the 3. Now I compare the 1.81 times 10 to the 4 with the 6.89 times 10 to the 4. The smaller one is the 1.81 times 10 to the 4. And the largest is the 6.89 times 10 to the 4. So now we need to write down the lakes in this order. So here is the smallest, followed by this, followed by this, followed by this, followed by this. Part C of the question, we have to calculate the difference between the areas of Lake Ladoga and Lake Tana. Give your answer in standard form, correct to 2 significant figures. Well, given this table, what we need to do is find out the difference between these two lakes. So the difference is 1.81 times 10 to the 4, subtract 3.20 times 10 to the 3. And if we work this out, we've got 1.81 times 10 to the 4, subtract 3.20 times 10 to the 3. And if we work this out, we get a value of 14,900. And what we need to do is write this in standard form, correct to 2 significant figures. Well, if we were to write this in standard form, if we imagine our decimal point here, we move the decimal point 1, 2, 3, 4 to the left, leaving us with 1.49 times 10 to the 4. And if we were to write this to 2 significant figures, we would have 1.50 times 10 to the 4. That's to 2 significant figures. Question number 2. Asmi, Beth and Callum share a flat. The monthly rent is £760. They share the rent in the ratio 2 to 3 to 3. How much does Beth pay for rent each month? Here is the ratio represented using a bar model. We've got 2 to 3 to 3. Altogether, they share £760. Now you can see we've got 1, 2, 3, 4, 5, 6, 7, 8 parts altogether. We can find out what each part is worth. If we do the calculation, 760 divided by 8, we get 95. So each part is 95. And if we want to find out how much Beth pays, we would have to do 95 multiplied by 3, which is equal to 285. For part B of the question, Asmi, Beth and Callum also share the fuel bill in the ratio 2 to 3 to 3. Callum pays £36 for fuel each month. How much does Asmi pay for fuel each month? Well, here is a bar model, again representing the ratio 2 to 3 to 3. What we know so far is Callum pays 36. So the total for Callum is equal to 36. We want to find out how much Asmi pays. We can first of all find out what each box is worth. 36 divided by 3 is 12. So we have 12 for each box, as demonstrated here. And so to find out how much Asmi pays, we have 12 multiplied by 2, which is equal to 24. So we have £24. Question number 3, we have to multiply out and simplify 3 multiplied by x plus 2, subtract x minus 1. Well, what this will be equivalent to is, well, we've got the 3 times by the x, 3x, 3 times by the 2, which is 6. Then we've got minus x. Then we've got minus negative 1, which is positive 1. And if we work out what this is equal to, 3x subtract 1x is 2x. 6 plus 1 is 7. So we end up with the expression 2x plus 7. Question number 4. Triangle A and triangle B are drawn on the coordinate grid. That's what we see here. For part A, we have to reflect triangle A in the line x equals 0. Well, the line x equals 0, that is the y-axis. So what we need to do is reflect triangle A in the y-axis, and if we do that, we end up with this triangle shown here. For part B of the question, we have to describe fully the single transformation that maps triangle A onto triangle B. Well, we are going from A to B. What we need to do is, first of all, find out the center of enlargement. And one way in which we could do that is to create ray lines. So here are some of our ray lines. We've got our center here, and if we take a look at this length, we've got a length of 8, and if we take a look at this length, we've got 2. So our scale factor, we are going from 8 to 2, we are dividing by 4 or multiplying by a quarter. So when we come to describe fully the single transformation that maps triangle A onto triangle B, we've got an enlargement scale factor 2/8, which is the same as 1/4, with the centre of 0, -6. Question number 5. Ling throws a 6-sided dice 300 times. The table shows the frequencies of their results. For part A, we have to complete the table to show the relative frequencies. So, we throw the dice 300 times. So for our denominator, we will have 300. And to find out the relative frequency, we need to divide the frequency by the total frequency. The total frequency is 300. 42 divided by 300 is 0.14. Then we have 27 divided by 300, which is 0.09. Then we've got 60 divided by 300, which is 0.2. Then we've got 39 over 300, which is 0.13. Then we've got 75 divided by 300, which is 0.25. Here is the completed relative frequency. For part B, Ling thinks that the dice may be biased. For the first part, we have to explain why the evidence from the table could support their opinion. Well, what we would expect if we have a unbiased dice is the relative frequency being the same. In which case, the relative frequency would be 1/6. That's if we have an unbiased dice. So this 1/6 for the relative frequency would be for a unbiased dice. Now we have to explain why the dice may, in fact, not be biased. Well, we would need a larger sample in that case to determine whether it's biased or not biased. We're only throwing the dice 300 times. We need to throw it for much more than 300 times to determine whether the dice is biased or not. Question number 6. A bag of sweets contains jellies, mints and toffees. The ratio of jellies to mints is n/2. The ratio of mints to toffees is 5:3n. You have to work out the ratio of jellies to toffees, give your answer in its simplest form. So we can use a ratio table for this question. We've got jellies, mints and toffees. The ratio of jellies to mints is n to 2. The ratio of mints to toffees is 5:3n. We need to determine the ratio of jellies to toffees. Now, do you notice for the first ratio we've got 2 parts, and for the second ratio we've got 5 parts. If we somehow get this m to be the same, then we can compare j to m to t. Now, how could we get the m the same? Well, the lowest common multiple is 10. The lowest common multiple of 2 and 5 is 10. So we want a 10 over here. Now, what do I multiply 2 by to get 10? Well, I multiply 2 by 5 to get 10, and I multiply 5 by 2 to get 10. 10. So if I do n multiplied by 5, I have 5n. And if I multiply 3n by 2, I get 6n. So that means that the ratio j to t is equal to 5n to 6n. We can simplify this ratio by dividing through by n, leaving us with 5 to 6. Question number 7. The scale drawing represents a park A, B, C, D. We've got the scale 1 centimeter represents 10 meters. A straight path goes across the park from B. The path is always the same distance from side AB and side BC. For part A, we have to construct the route followed by the path. Show all your construction lines. Well, what we need to do here is find a ruled bisector of angle ABC. And that's because we are told in the question the path is always the same distance from side AB and side BC. So, if we do that, we want the bisector of the angle shown here. So the first thing we can do, put the pointy bit of our compass here. And then what we do is we draw an arc like so, which intersects AB, and another arc here, which intersects BC. And then if we put the pointy bit of our compass on this intersection point, we can draw an arc like so. And if we do the same thing, maintaining the same radius, and draw an arc like so, what we now need to do the path, if we grab a ruler like so, the path is this path here. So what we are saying is we've got a straight path from B, and this path is the same distance as it is from AB and BC. Next, for part B, the bench is to be placed on the path. The bench must be no more than 50 meters from C. We have to construct the locus of the possible positions where of the bench, indicate clearly on the diagram where the bench can be placed. The first thing we need to do is, so if we use the scale, 1 centimeter represents 10 meters, we've got 50 meters from C, so if we find a radius of 5 centimeters, because if 1 centimeter represents 10 meters, then 50 meters will be represented by 1 centimeter on our diagram. Then from C, what we do is we intersect this path So we intersect the path here, and then we intersect the path here. So our points of intersection where the path could be here, or the path could be here. Question number 8. For part A, train A travels 120 km at a constant speed of 80 km per hour. Train B travels 120 km at a constant speed of 50 km per hour. How many more minutes does train B take to travel 120 km than train A? Well, for train A, we can find out the time it takes. We've got the distance, 120 km, divided by the speed, 80 km per hour, and working this out, we get 1.5 hours. Now, if I multiply 1.5 by 60 to convert it into minutes, I get 90 minutes. So the time it takes for A is 90 minutes. Similarly for train B, the time it takes, we've got the distance 120 kilometers, we divide by the speed 50 kilometers per hour, and working this out we get 2.4 hours. And if I multiply 2.4 by 60 to convert it into minutes, we get 144. So B takes 144 minutes. We need to find out the difference between these. So 144 subtract 90 is 54. So therefore, train B takes 54 minutes more to travel 120 kilometers than train A. For part B of the question, train C has a speed of x kilometers per hour. We have to write an algebraic expression for train C's speed in meters per second. Well, we've got x kilometers per hour. We want to convert this into meters per second. And if I multiply by 1000 and then divide by 3600, I would convert to meters per second. So I multiply the x by 1000, so I have 1000x meters. And then the hours we can convert into seconds by multiplying by 3600. So altogether we've got 1000x over 3600 meters per second. And if we simplify this, we get 5x over 18 meters per second. Question number 9. The width W of a kitchen cupboard is 60 centimeters, correct to the nearest centimeter. For part A, we have to complete the error interval for the width W. Well, if we are rounding to the nearest centimeter, then for the lower bound, we would have 59.5. For the upper bound, we would have 60.5. And therefore, for our error interval, 59.5 is less than or equal to W, which is less than 60.5. For part B, 6 of these kitchen cupboards are to be placed side by side along a kitchen wall. The wall is 363 centimeters long, correct to the nearest centimeter. We have to show that the 6 cupboards may not fit along the wall. Now, the first thing we can do is find the error interval for the wall. So for the error interval for the wall, if the wall is 363 centimeters long, the lower bound, that's equal to 362.5. This is going to be less than or equal to the wall, which is less than 363.5. Now, what we're saying here is, if I've got 6 of these cupboard lengths, will all of those lengths together fall within this boundary? So, the way we can look at this is to think, well, if I had 6 multiplied by 59.5, and if we work out what this is equal to, we get 357, and if we do 6 times by 60.5, we end up with 363. So the reason why the cupboards altogether may not fit along the wall is because we think to ourselves, well, this 363, that could be the length of all the 6 cupboards. So we could have 6 cupboards over here equaling 363 centimeters. But the problem is the wall in of itself. So here is our wall. This wall may only be 362.5. So because of that, because the 363 is larger than the 362.5, the 6 cupboards may not fit along the wall. For the next part, we have to find the upper bound of the space remaining if 6 cupboards do fit along the wall. So if we want the upper bound of the remaining space, we want the largest space left over as possible. And if that's the case, what we need is our upper bound of the wall, the 363.5, and then we subtract from this the smallest possible length of the cupboard, which is 59.5. But then we have to multiply by 6 because we've got 6 cupboards. And so if we work out what this is equal to, we get 6.5. So therefore, the upper bound is equal to 6.5 centimeters. Question number 10. An equilateral triangle, a regular 10-sided polygon, and another regular polygon meet at a point. And that's what we see here. Now, for part A, we have to show that angle A is 156 degrees. Well, what we need to do is find out what the interior angle is of the regular 10-sided polygon, the equilateral triangle, from which we can find the interior angle A. Now, before we do anything else, what we can do is extend the line here and then find out the exterior angle of a regular 10-sided polygon. The exterior angle of a 10-sided polygon, that is equal to, well, we would have 360 degrees, and then we would divide this value by 10, giving us a value of 36 degrees for the exterior angle of the regular 10-sided polygon. And then we can find out the interior angle marked here. The interior angle of this 10-sided regular polygon will equal 180 degrees, subtract the 36 degrees, which is equal to a value of 144 degrees. So the angle marked here is 144 degrees, which means as well this angle is also 144 degrees. The angle here, because we have an equilateral triangle, this angle is 60 degrees. And then we can find out the value of the angle A, recognizing that the sum of the angles around a point equal 360. We would have 360 degrees, subtract this 144 degrees, subtract the 60 degrees. It turns out indeed angle A is equal to 156 degrees. And that's exactly what we wanted to show. For part B, we have to work out the number of sides of the other rectangular polygon. Now, the way we can approach this question is to think, well, if we have an angle of 156 degrees, we can extend this line to find out the exterior angle of that regular polygon. So the exterior angle will equal 180 degrees, subtract the 156 degrees. It turns out the exterior angle is equal to 24 degrees. So we have 24 degrees for the exterior angle of this regular polygon, and therefore to find out the number of sides, we will call the number of sides n. That is equal to 360 degrees divided by 24 degrees. So the number of sides equals 15 degrees. The number of sides is equal to 15. Question number 11. In a class of 30 students, 17 study French, 20 study German, 2 do not study either subject. we have to complete the Venn diagram. Well, if we let the intersection point equal x, then for French only, we would have 17 subtract x, and for German only, we would have 20 subtract x. We know that the entire set is equal to 30. We've got 30 pupils altogether. With this, we can form an equation. So we have 17 subtract x plus x plus the 20 subtract x plus this 2. The result of this is equal to 30. And so what we can do is solve for x. So simplifying this equation, we have 39 subtract x equals 30, which means x is equal to 9. So we've got 9 over here. 17 subtract 9 is 8. 8 goes here. 20 subtract 9 is 11. 11 goes here. We have now completed the Venn diagram. For part B of the question, 2 of the 30 students are chosen at random. We have to calculate the probability that one of these 2 students studies French but not German, and the other studies German but not French. You must show your working. So to do this question, what we're saying over here is, out of the 30 students, we've got 2 students. They can study French but not German, so that means French only. Or they could do German only but not French. Now the probability of studying French only out of 30, that will be 8 of them. And then what happens is 29 are left over. And of these 29, 11 of them would be studying German. Or we could have this the other way around, where instead we say, out of the 30, 11 of them study German only, and then we've already chosen one of the pupils. That leaves 29 remaining. Of those 29, 8 of them study French only. So if we work out this probability as required, we have 8 times by 11 divided by 30 times by 29, and then we times that by 2 because we've got twice of that, and it turns out we have 88 over 435. Now the decimal equivalent of that answer will be 0.202 to 3 significant figures. Question number 12. A solid metal sphere has mass 235 grams. The density of the metal is 7.78 grams per centimeters cubed. We have to show that the surface area of the sphere is 46.9 centimeters squared. Correct to 3 significant figures. You must show your working. And we've got the volume of a sphere with radius r, that's 4/3 pi r cubed, and the surface area is 4 pi r squared. Now, if we have been given the mass and the density, we can find out the volume. So therefore, the volume of this sphere, that will be equal to 235 grams divided by 7.78 grams per centimeters cubed. So we have 235 divided by 7.78, and it turns out the volume of the sphere is equal to 30.205 etc. centimeters cubed. Now, what we can do is use this information to find out what the radius is. So knowing what the volume is, we can find the radius, from which we can find the surface area. So we have the volume 30.205 etc. That is equal to 4/3 times pi times by the radius cubed. So let's find out what the value of the radius cubed is. That's equal to this divided by 4/3 pi. It turns out r cubed is 7.211 etc. And therefore, if we cube root, we end up with r equals 1.931 etc. centimeters. So now we can find out the surface area, substituting into 4 pi r squared. The surface area is 4 times by pi times by 1.931 etc. squared. And so, working out the surface area, we've got 4 pi multiplied by this radius squared. It turns out we get 46.903 etc. centimeters squared, which to 3 significant figures is 46.9 centimeters squared. And that's exactly what we wanted to show. Question number 13. A straight line passes through the point 81 and is perpendicular to the line y equals 4x minus 2. We have to find the equation of the line, giving the answer in the form y equals mx plus c. Well, if we consider the y equals 4x minus 2, then this would have gradient of 4. Now we want the perpendicular gradient. The perpendicular gradient is equal to the negative reciprocal of this, negative 1/4. Now if I substitute this point into y equals mx plus c with this gradient, we can find the value of c. So if we consider the point 8, 1, we've got our value of y, which is 1, that's equal to m, which is minus 1/4, times by x, which is 8, plus c. We've got 1 equals, now minus 1/4 times by 8, that's equal to minus 2. And then we add on c, which means c is equal to 1 plus 2, which is 3. Now that we've got c, we can therefore conclude that the equation of the line is y equals minus 1/4 x plus 3. This is the equation of the straight line. Question number 14. Y is inversely proportional to the square root of x. When y is 5, x is 36. We have to find a formula linking x and y. Well, we've got y, which is inversely proportional to the square root of x. So we have the following statement. And if this is the case, we can convert this into an equation. And the way we can do that is to use the constant of proportionality, which we will call k. In other words, we can say that y is equal to some constant k over the square root of x. We've got the condition y is 5, x is 36. So when x is equal to 36, y is equal to 5. So we have 5 equals k divided by 36 square rooted. 5 is equal to k divided by 6, from which we can conclude k is equal to 30. 5 times by 6 is 30. And knowing what k is, we can therefore conclude y is equal to 30 divided by the square root of x. For part B, we have to find the value of x when y is 20. Well, when y equals 20, we have 20 equals 30 divided by the square root of x. And if I rearrange, we can then say the square root of x is equal to 30 divided by 20. In other words, the square root of x is equal to 3 over 2. And to find out what x is, we would have to take this 3 over 2 and then square it. And if I square 3 over 2, we would get 9 over 4. So x is equal to 9 over 4. Question number 15 for part A, we have to show that the equation x cubed subtract 5x subtract 1 has a solution between x equals 2 and x equals 3. Now, the first thing we will do is notice that the right hand side is equal to 0, so the left hand side we can set equal to f of x. So f of x, we can state that f of x is equal to x cubed subtract 5x subtract 1. That's what f of x is. And what we can do is substitute in x equals 2 and x equals 3 into this. So if I find out what f of 2 is, I replace the x with 2. So we would have 2 cubed subtract 5 times by 2, and then we subtract 1. And working out what f of 2 is, you will see that f of 2 is equal to -3. And if I work out what f of 3 is, we would have 3 cubed subtract 5 times by 3 subtract 1, and if I work out what this is, we get 11. We have a result which is less than 0, we have a result which is greater than 0, and therefore what we can see then is we have a change of sign, and f of x is continuous in the interval 2 to 3. So we have a solution between x equals 2 and x equals 3. Now, one way to approach this question is to create an iterative formula. If I begin with the formula x cubed subtract 5x subtract 1 equals 0, then I can rearrange this to say that x is equal to 5x plus 1 cube rooted. So what I can now do is come up with an iterative formula to say that x n plus 1 equals 5xn plus 1, and then this result is cube rooted. So what we can do is start off with a value in between 2 and 3. For example, we could start off with x equaling 2.5. And if we substitute this into our iterative formula, x0 is 2.5. So working out the value of x1, well, here we can use our calculator. Start off with 2.5, then we've got the cube root of 5 times by our previously stored answer plus 1. x1 is equal to 2.381101,578. x2, we have a value of 2.345623,839. x3, we have 2.334827,203. x4, we end up with a value of 2.33152166. And let's see what would happen when we continue. When we continue pressing equals, it stops converging after this value. So x is equal to 2.3305.874, which means if I were to solve for x to one decimal place, we have 2.3, because our solution doesn't converge anymore. Question number 16. The following kinematics formulas may be used in this question. We've got v equals u plus at, s equals ut plus a half at squared, v squared equals u squared plus 2as. The initial velocity of a particle is 20 meters per second, so that means u is equal to 20. Then we've got the acceleration being minus 8. So we can say that a, the acceleration, equals minus 8. And we are told that the particle has travelled 25 meters after t seconds, which means s is equal to 25. And with this, we have to show that 4t squared minus 20t plus 25 equals 0. Now, what we can do is substitute into s equals ut plus a half at squared. The reason we want to substitute into this, well, my show that involves a t squared. So if I substitute these conditions into s equals ut plus a half at squared, we've got s, which we've just said is 25. That's equal to u, which is 20, multiplied by t, plus 1/2 times by a, which is minus 8, times by t squared. 25 equals 20t minus 4t squared, and if we take everything over to one side, we can therefore conclude 4t squared minus 20t plus 25 equals 0, and that's exactly what we wanted to show. Now for part B, we have to solve 4t squared minus 20t plus 25 equals 0. Well, what we can do is factorize this as a perfect square. If we start off with 4t squared, subtract 20t, and then plus 25 equals 0, then factorize this as 2t minus 5 all squared, and you'd find when I multiply that out I get this expression. So we set this equal to 0 because it's an equation, and if I solve for t, I only get one value of t. I only get t equals 5 over 2. This is my only solution. And then for part C, we have to show that the particle is stationary when it's travelled 25 meters. Well, we know when it travels 25 meters, t equals 0. And that's when travelling 25 meters. And we know t equals 0 when we travel 25 meters. And if that's the case, rather t equals 5 over 2, because that's what we worked out over here. If we use v equals u plus at, we have v equals u, which is 20, plus a, which is minus 8, times by 5 over 2. And what you'll find is we get 0 for this. V equals 0. And therefore, we can conclude that the particle is stationary in this case. Question number 17. The diagram shows a pyramid ABCDE. The pyramid has a square horizontal base ABCD with side 5.6 centimeters. The vertex E is vertically above the center of the base. The height OE of the pyramid is 6.8 centimeters. You have to calculate the surface area. You must show your working. Well, what we can do to find the surface area is, well, what I need is the area of the triangles. And for me to find out the area of the triangles, the face, so that would include this as the face. We need to find out the area of one of these. What we need to do is find out the height of this triangle. Now here we can see an inner triangle. Now this green section here, if we find out what this is, this would be the height of the triangle shown in red. Now this section in blue is half of the 5.6, which is 2.8 centimeters. So what we can do is find out the height of this triangle using Pythagoras. So using Pythagoras, we have this height, we'll call it h for now. So that is this length here. That's equal to, well, what we would have here is 2.8 squared plus, now we're going to add on 6.8 squared, and through Pythagoras we need to find the square root of this. So if I work out what h is, what you will find is h will equal 7.353, etc. centimeters. Now what I will do is I will redraw this triangle with all the information I know. What we've just worked out is this 7.353, etc. We've got this base of the triangle, which is 5.6. So this is the base of the triangle. And therefore what we can do is find out the area of one triangle we would have 1/2 times by the base of 5.6 and then we times this by the 7.353, etc. So if I work out what this is, the area of the triangle, I've got 1/2 times 5.6 times that. The area of one of those triangles is 20.59, etc. centimeters squared. So that's the area of the triangle. Now to find out the total surface area, we've got 4 of those triangles, so I've got 4 times by 20.59, etc. But then what we've also got is the area of the square, which is 5.6 squared. So this would correspond to the square, and here we would have the 4 triangles. So if I work out the surface area then, 4 times by this plus 5.6 squared, we get 113.723, etc. centimeters squared. So we've got 114 to 3 significant figures. Question number 18, we have to rearrange this formula to make y the subject. Well, if I cross multiply, we would have 2 multiplied by 5y plus 2 equaling y times by 3t minus 7. Now if I expand the brackets, I would have 10y plus 4 equaling 3ty minus 7y. Now, if we take everything over with a y on one side and everything without a y on the other side, well, adding 7y to both sides, we would have 17y, and then I subtract this 3ty, and if I take this 4 to the right hand side, we would have the following. And now if I factorize out a y, we would have y multiplied by 17 subtract 3t equals minus 4, which means if I divide through by 17 minus 3t, y is equal to minus 4 divided by 17 minus 3t. So here is our required formula.